Hello, everybody. Hey, Tammy. Thank you, everybody, for joining the data and machine learning stream. Sorry for the little bit of a delay. My Wi-Fi was like going in and out, and I wasn't really sure what was going on, and I wanted to make sure it was good before I started streaming. So if y'all haven't already checked in, make sure you check in. I've got it scrolling at the bottom of the screen, but if you need it in the chat, here it is. No, I added an extra one. That's so unfortunate. Okay, don't use that. That is wrong. It's gonna be /events/12911. There you go. Okay, ignore the first link. It is in fact the second link. Yeah, check into the event. If this is your first Global Hack Week, or you haven't gone to that many, we usually check in so that you can get swag and so that you can get like participation for being here, because you're spending a lot of time with me. It's going to be the next 2 hours, so I want to make sure that you're getting the credit for that. Yeah, so I see a couple new people joining in. Hello. We're just gonna check in at that link and then I'll get started in a little bit. So if y'all didn't know, hopefully you like wanted to join the stream and you didn't just see the Discord announcement. You were like, ooh, a stream, and you joined. But I'm basically going to be covering data and machine learning. I usually do introduction streams where I'm like talking about concepts that are related to the Global Hack Week. So for this time, it's like data and machine learning. So specifically, I'm going to be talking about basics that you'll need to know about data for machine learning, meaning things like pandas, different data sets that are important, how to clean up data, how to use different models with data, and things like that. So I'm going to be covering a lot of stuff. It's not just going to be me like talking to you, and it's also not just going to be like us coding and nobody talking to you. It's going to be a mix of both. So I'll be talking to y'all about some concepts, and then I'll also be coding along with you to help you gain some real experience with coding and also with these concepts. And then at the end, I'll just go over like a quick recap about the concepts and like a little more in-depth explanation. Yeah, so yeah, we're going to be coding on Google Colab today. I am a very big proponent of VS Code. I really like VS Code, but I've started liking Google Colab more just because it's like natively built into the browser. So I don't have to do this like weird little switcheroo when I'm like switching back and forth between the screen and the comment and VS Code and everything. It's just easier for me to do it on Google Chrome. But if y'all want to use VS Code, feel more than free. It's just going to require some additional commands with like running the code and seeing some of the models come. So I would recommend getting Google Lab. Like you don't have to get anything. You basically just click on that and then make your own account. And that's literally all you have to do. So yeah, if you haven't already, make sure you go to that link and open up a new collab notebook. The cool thing is you also don't have to call it like a separate file depending on what type of file type it is. It just automatically understands what you want, which I think is super cool. So yeah, we're gonna get started in just a little bit. But before that, how's everybody doing? I don't know if it's like late or early for y'all, but how's it going? Are you tired? Very wide awake if you just woke up. I like to know what my audience is thinking and how they're feeling before I jump into the stream so I can adjust accordingly. So if you have any thoughts, speak now so that I can make the stream more like active or more calm or whatever. Yeah, just let me know what you're thinking. But if I don't get too many comments, that's okay. I'm just going to move on probably a little bit. I don't have any slides for today. I have the slideshow up so that I can do like my MLH or intro, and then I'll switch to the content. Ooh, hello. It's good. It's 4 p.m. in LA right now. You finished all your Sunday chores. Okay. LA is very fun. I went there for a hackathon for Hack Mesa. And I loved it so much. There were so many like grocery stores and like really great places to eat. So I'm a very big fan of LA. And I say that, but like I haven't even gone that many places, but it was still super cool. Sunday chores is great. I usually do that too. I usually like I try to be clean throughout the week, and I usually do all the like major cleaning stuff and like all the major chores on the weekend. So I totally get that. That's cool. Tammy says, I'm not too bad. It is midnight here. I came from the sentiment analysis one, which was fun. How are you? Ooh, Midnight. Oh my gosh, must be really late for you. Thank you for coming. Where are you based? I'm curious. I feel like I'm starting to get more into like understanding time zones and like realizing where people are based on their time, but I'm still like still getting there. I think 6 hours is like UK British time. I don't know. Link to the challenges. Yes, yes. Let me get that for you. Uh, they always do the short links like mlhlink.challenges and like that really helps, but sometimes I forget the short links and it's not good. um, there it is. There's definitely a short link for that, but for now, there's the challenges for Data Week. Feel free to click on that if you are interested and if you want to go through some of the challenges. This is my first stream in this month, week streams. Yay! Okay, I'm glad to be your introductory stream on day 3. Yeah, this is going to be my only technical stream. I used to do a lot more and then I started university and I'm very busy during the week. So this is my only technical stream, but I am coming back for closing. So if you're interested, I will be doing closing. We love seeing people at closing and talking to hackers about the Global Hack Week. So feel free to join them. Midnight for me too. Oh my gosh. Y'all are warriors for being up this late. Yay, I was right. Very cool. Yeah, I think I'm getting ahead on time zones. I think I'm finally starting to understand. But okay, glad to see some check-ins from y'all. Good to see that everything, let me get rid of that starting soon. Glad to see that everything is going good. Everything's very chill. I'm probably gonna get started, but if anyone else comes along new, or if you just came along new, just make sure you check in at that link. There's not gonna be too much that you miss if you go through, like come through late. Everything that I code is gonna be on the screen, so. Yeah, okay. This is me. Hi, I'm Vashni. I'm a coach at Major League Hacking. I have a blahaj. I always show my blahaj and I always forget to get it out. So let me go get my blahaj. Like I was like streaming at my internship before and like I had my blahaj on the table right behind me, but now I'm like actually in my room back at home. So it's like hiding over in the corner. But this is my blahaj. Life-size blahaj, very gigantic. I feel like I always hold my blahaj wrong, but I don't really know how else you're meant to hold it. But this is my blahaj. I used to have other fun facts, but now I just think my only fun fact is that I have a blahaj because it's just so adorable. Yes. I did have it in the earlier morning stream for the Today in Global Hack Week stream with Vincent. And yes, it is very cute. I hope it never deflates or like loses stuffing because I think that would be really tragic and I'd be really sad. So I hope it maintains its like puffiness. And I'm like, what do y'all think? I feel like I want to take them on airplanes because they're so nice and they're like really nice pillows, but they're also like a lot. I feel like it's a big commitment to take that because you can't stick it in your carry-on and you can't stick it in your backpack, so it's kind of just there. Yeah, I don't know. Let me know what you think, but I don't think I'm gonna take that on the plane with me. Yeah, okay, so that's like it for slides. I just wanted to do my intro. I should put that back on just so we're not like focused on my face while I talk. But yeah, so if you don't know already, today's stream is going to be about data and machine learning. Specifically, it's going to be about data pre-processing and engineering features or feature engineering. So basically, this matters a lot. And like this is a very introductory stream about how to go into machine learning, mainly because in every machine learning project that you do, whether it be through like research or university or in your job, the data is going to be the foundation of all of that, hence Data Week. It's very important because data is the foundation for all machine learning projects. So you can have this like really fancy algorithm, like for example, like a really deep like neural network with like billions of parameters that's like very, very advanced. But if your data that's feeding the machine learning model is messy, then the predictions by your model are going to be like super useless. So this is more of a how to process data to use it in machine learning stream. Hopefully none of y'all are disappointed by that. But yeah, this is more about how to process your data and how to go through different data sets and kind of clean it up and make new columns or make better columns out of existing columns to help you have better data in general. So yeah. we are basically going to start with raw data sets. I picked two, I think, interesting data sets that I hope y'all will find interesting. I was trying to pick like popular culture data sets that would make sense to a wide range of people. Hopefully I did do that. So we're going to take raw data from these data sets. We're going to clean it, transform it, and then basically turn all of this data into something that we can meaningfully use. When I say clean it, obviously, for those of you beginners, I don't mean like clean the data as in like take pieces out or like physically like clean it and make it like organized. I mean more of like accounting for missing values and making sure that the data, I guess, is also organized. But clean mainly means organize, kind of standardize the data, make sure that like if you have missing values, they're marked as such and they're not just like NaN or something like that. So yeah. Once we clean up our data and assign it, we're basically just going to be feeding it into a couple of machine learning models so that we can see how that pre-processing that we do with our data affects the performance. Obviously, the end result is that when we do a lot of pre-processing, that's going to increase our performance. But I'm showing you that, and you're going to be able to do that by yourself too, just so that you can see how important it is. Because I feel like a lot of times with machine learning, it's like very easy to kind of just get like fed it or not fed into or like sucked into the thought of like, oh yeah, I just like worked on the model and worked on the data and like I don't need like pre-process or anything like that, but it is very important. So yeah, so we're going to be basically using two different data sets for this stream, and again, I tried to pick like kind of reasonable data sets that were beginner friendly and also kind of understandable. So I used the Titanic data set. Hopefully that doesn't upset anybody. It just had really good like column names. But if you don't know what the Titanic is, it was like this really big ship that sunk. And yeah, it was like not great. It was like a tragedy. But the reason why I used it is because the Titanic had a lot of really organized data about the passengers and a lot of different pieces of data that we can use. And then I also used the California housing data set. I was kind of looking for something similar to the Titanic in terms of like rooms and like median age of like house versus person. So I used the California housing data set too. This is just like a purely numeric data set. It doesn't have as much like categorical and demographic data as the Titanic data set does. So I guess the two differences between the data sets with the Titanic, since it's more categorical and demographic data, it's really good for classification. Whereas with the California data set, it's really great for regression because it's mainly just numeric data. So by the end of the stream, my goal is that you'll not only know how to pre-process data, but you'll also be able to understand why each step of pre-processing matters, because it's really important, and it's important that you do that before projects as well. So yeah. I guess we can just get started with Google Colab. So hopefully y'all have signed into Google Colab. And let me just pull it up. So yeah, while I'm doing this, make sure you are in Google Colab. You've opened up a notebook and add that in. Okay. Yeah, see, this is why it's so helpful, because now I don't have to switch between like actual physical tabs on Google Colab. I can just do share your screen, which I think is helpful. But yeah, we have Google Colab. Let me know if anyone's having any trouble getting into Google Colab or yeah, like any trouble with anything, just let me know. There's no like notifications for the chat, but I do check back very frequently. So yeah, just let me know if something pops up and I will be more than happy to help you out. But we're gonna start coding. So something really important is the Pandas library. I'm sure y'all have heard of it, but if you haven't, the Pandas library basically just provides us like data frame and series objects so that we have structured data. And it's really useful for like structuring our data and also just like to learn as a concept for machine learning and data projects because it'll be used a lot. So we're going to import pandas. You can honestly just leave it as import pandas. I usually do like as PD, and a lot of people in the data science field will do that as well, mainly because it's just easier to refer to it as PD instead of pandas. I get it. It's like 6 letters versus 2, but that will make a difference when you're trying to code later and you want to keep your code clean. So I'm going to import pandas as PD, and then I'm going to do from sklearn dot data sets, and here I do see that it's auto-populating my code. I'm not going to accept that for now because it doesn't know what data set I want, and I don't know if I trust the autoline completion tool as much as I should, because I know what I want, but it doesn't really know what I want. I'm going to take out this banner, by the way, for the check-in. If y'all still need the check-in, just let me know and I can post it again. But yeah, feel free to use the autoline completion if you want, but it might not give you the code that you need / want for this stream. So yeah, I would recommend just following along with me, but and ignoring your inline completion. Probably in the future when you start building your own projects, it can help you, but I just think for now it's helpful to learn and code by yourself. So we're going to do from sklearn.datasets, and we're going to do import, and we're going to do fetch California housing. So this is the California housing dataset that I was talking about. So just as a quick recap. So the first statement is import pandas as PD. That loads the panda library and that helps us reference it as PD. And the second statement is something I really talk about. So this is importing a function. And basically what this is doing is it's fetching the California housing data set directly from skykit-learn, sklearn.datasets. And this will basically return to us a very organized, very structured object that has data, feature names for different features of the data, and also target values for different variables in the data. So that is very helpful as well. And so now that we've imported the California housing data set, now we're going to import the Titanic data set. So this is one way that you can import data sets. You can do it from skykit-learn. You can also just use the straight URL. So this is another reason why I use 2 data sets, because there's a lot of different ways to import different types of data. And I just wanted to show you both. So also I might take some pauses during the stream. I don't know why. I've been having a little bit of trouble breathing lately. So I might just pause for a little bit and just deep breath. So if I pause, your internet is not glitching. I'm just taking a quick break. So back to the URL, do HTTPS, and that is not right. See, it's auto-populating based on the housing data set. But I want to use the Titanic. No, wait. Yeah, I want to use the Titanic. So I'm going to do content.com. And this is nothing that you would need to know to code. This is just the name of the data set specifically. I'm not reading this from memory. I have this written down so that I won't mess it up. And then after I do that, I'm going to set Titanic equal to pdread _ CSV, and then pass in that URL as our parameter there. So basically here what I'm doing, actually let's see what that link looks like. Let me just show y'all. Okay, it says the site can't be reached. Let me make sure I didn't type something wrong there. MWA. Sorry, I'm just double checking. Did I typed everything right? There you go, .com instead of com. That was a stupid typo. That's okay. Yeah, so this is what it looks like instead. So this is the data set. Can y'all see that? Yeah, you can. Yeah, so this is what the data set looks like. Just a couple pieces of data from the Titanic. And you can see that you have the columns, the headers here. Survived being number 1. Again, if you are joining new, I was mentioning this is from the Titanic tragedy, and the reason why it says survived is because a lot of people didn't survive. So that was a key piece of metric data. Sorry if this is a little grim. I just thought it had really good columns. Sorry. It might have been a little too grim. Name of the code editor is Google Colab. I sent a link earlier here. You can click on that link and you can make an account. You can also just base it based off your Google account. That works as well. Yes, thank you, Tammy. Can you please help with yeah, for sure. That is definitely a wordful or mouthful. It's something really big to type. So there you go. Hello, 404. I haven't seen you at one of my streams in a while. hello, welcome back. Oh my god, that's my bad. I'm sorry. I don't want to like remove my face because then you're just looking at a screen. Let me see if I can zoom in. Does that help at all? That does help. Okay. Yeah. Weird old stranger. Let me know if that helps you a little bit. I can also copy and paste pieces of code that might be a little bit more complex. Yeah. But if you needed that link, sorry, there it is. Yeah. This is not your first day, Bridget. You do this every time. I feel like you need to come up with more unique jokes. You got it. You can do it. Yeah, Aviolax is correct. You mean for this month. They're calling you out. They know the truth. It's 5 a.m., so I should probably sleep. You probably should. That's quite late. Well, I hope you mean that you woke up at 5 and you're watching this, not that you stayed up, because that would be really disappointing, and you should sleep more. But back to the code. So let me explain a little bit about what this is. So basically, this URL, obviously a URL, but it's a string that's pointing to this CSV file on GitHub. I know y'all have probably seen GitHub, and this is not really what GitHub looks like, but it is on GitHub. It just is loaded as a CSV file, so it looks a little bit different than what you're used to. Yay, glad that helps. That is not good. You should definitely sleep more. I feel like we've talked about this before, and I feel like other streamers have talked about this with you, but yes, to all of you, if you need sleep, sleep, because all of these sessions are being recorded. The only difference is that like you get to ask your questions live versus after, and obviously community, but if it's late for you and you want to sleep, please go ahead and sleep. That is my spiel of the day about sleeping instead of watching streams. So yeah. This is a URL pointing to that CSV file on GitHub. And then we've got this command right over here. And what this does is it's reading the CSV file from the URL into a pandas data frame, hence why we imported pandas over here. And pandas basically infers the column names and the data types. So you can see in this, like we have the column names here, like there's not much to infer, but it's more that we're not explicitly naming the column types, and it's just easy for pandas to put it into like kind of a data frame object and structure the data. So that way it's able to also keep the data types. So that way also, like with pandas, it has a lot of inherent features like that we're not going to go over because like I could talk about pandas all day. But with pandas, you have numeric columns, which might be like age or like class or something like that. And these types of numeric columns are converted to floats or ints. And then we have text columns. Those are converted to object types. So pandas just help standardize things instead of having it in formats that I guess don't really help us much. So yeah, that's a little bit about that. And I guess the end result of this, if you're wondering, is that this Titanic variable now holds a data frame that contains all the rows and all the columns of the Titanic data set that we were looking at earlier. So we're going to do something similar with the California housing data set. So we're going to do housing equals, and yeah, again, it is auto-populating that for me, but I think we need to learn how to write our own code. And we're going to pass an as frame, and we're going to set that, I guess don't need spaces. Set that equal to true, and then I'm going to do housing, and I'll do housing frame. So basically what I'm doing here is I, like this statement right here, I'm downloading the California housing dataset and returning a bunch object this time instead of a data frame. And like bunch is kind of similar to a dictionary, if you know Python, basically just like key value pairs. And if you don't know like Python dictionaries, the reason why I say key value is because usually in a dictionary you look up like a word and then there's a value associated with it. So the word is the key, the value is the value. So think about it like that. And then here in this as frame equals true statement, I'm returning a specifically pandas data frame instead of a numpy array, which is what would be the default if I just use the California housing data set, but I want to use pandas here because pandas is pretty useful. And then here I am getting that data frame object with all the features and all the target values in one table, and I'm setting that to housing df. So again, just like we had in Titanic here, now we have this fully structured pandas data frame object stored in housing DF as well. Okay. I'm not seeing any questions. I'm going to keep going, but remember, if you have any questions, just let me know. Don't think like, oh, she's talking, she's probably busy. No, I am checking very frequently, so just let me know. And then we're going to print a couple of values just so y'all can see it. Like, I know you saw the Titanic data set, but I think it's cooler to see it like in, I spelled Titanic wrong. I think it's cool to see it in Google Colab so that you can see the values like formatted really pretty. So Titanic, and we're going to do Titanic data set. Do colon to demonstrate that data, and then we're going to do print Titanic dot head, and then we'll do double quotes, backspace, n. If you haven't used that, let me get confused. I think that's a backspace. If you can't find that backspace character, it's usually above your return key. Yeah, I think different keyboards will look different, but typically it is above the return key. If you need help finding that, just let me know. And then we're going to do print, and we're going to do housing data set this time. Not the Titanic data set, different data set. Oh, I forgot my quotes. That's unfortunate. And then we're going to do print housing underscore df head. Perfect. So you might be wondering what dot head is. I think it's a really weird function name because I don't know, why wouldn't you just do beginning or something like that? But I didn't make it, so. But basically the head function just shows the first 5 rows of whatever data set, whatever object you have. And I think this is really helpful because obviously the data set is going to be really big. It's like all the passengers on the Titanic, all the values they gathered from California housing. So it's really helpful to get just those first 5 rows so that you can see like column names, you see values, and so that you can see like kind of initial patterns in the data set. Obviously you won't be able to see all of the data given that it would be really, really hard to show all of that. But it would be pretty good to just do head so that you can see like what those different values are. So that's why we use head. And then I've got this like print statement here. And that's mainly just so that we can see them. Like I can show you what the data looks like. And then I like talked about this a little bit, but basically this just adds a blank line. This doesn't really do anything for your code. It just helps it make it more readable. Since it's 2 different data sets, I'm adding in that blank line so that we can like clearly separate between those 2. So I'm gonna click this little red, or not red, I don't know why I said red, black arrow here to run the data. And it'll load. Oh, why is it upset? Oh, it's because I did capital F. It is actually lowercase f. See, that's a funny error because like I had to like click the shift key to do that, and Obulix is correct. You caught the error. Yes, it is the small letter F. I think that's funny because you have to manually click the shift to get the capital F, so I don't know why I did that, but it's fine. Yeah, okay. So that works. This is our output. I'm gonna zoom out a little bit, sorry y'all, but you can't really see the output if I'm that zoomed in. But like you can see, this is the Titanic data set. We've got our different columns. They're kind of split across 2 different lines. You can see the town that they left from. I don't really know why it's like survived versus, oh, I do. That's such a stupid thing to say. Survive just means, I guess, like, did they survive from the attack? And alive means, are they alive right now? Yeah, sorry. I don't know if you can tell that I'm like a little tired. My brain's not functioning as much as it should be. But yeah, this is the housing data set too. You can see they have a lot of different fields. Like they got like population, latitude, average rooms, average bedrooms, which is super cool. I don't really know what the difference is between average rooms and average bedrooms, because I would think a bedroom is a room. I don't really know what extra rooms people in California have. Maybe they're counting like a living room as a room because it has the word room in it. I don't know. But yeah, this is just a quick example. So a really good way that you can see some of the values in your data without explicitly printing them out or going and looking at them is doing this head function. It's actually very useful. Yeah, so that's it. And then we're going to add another code line here. So basically, I'm going to add new code cells after I run the code every time. You don't have to do that. I mainly just do that just so that it's like more organized and so we can clearly see like what code is causing or resulting in what output. So you don't have to, but I just find it easier to keep myself organized. So here I'm going to do print, and I'm going to do Titanic.describe. I'm going to do include equals all. So here what I'm doing is for each of the numeric columns, I'm basically asking them to compute like count, mean, standard deviation, min, like max, like all those different values. And then for the categorical columns, the ones that are like, what town did you leave from, et cetera, it's going to show you the count, unique values, like the most frequent values, and like the frequency of the most frequent values. So it basically just ensures that we have both the numeric and the categorical values, and we're not excluding one over the other. So these are just like a couple different ways that we can kind of summarize our data. And then I'm also going to do another one. I'm going to do print. Titanic is null, and then I'm going to do sum. So what this one does, let me go one by one. Oh, I spelled Titanic wrong. The is null function here. So this is going to return a Boolean data frame. So we talked about data frames. Now we have Boolean data frames where here true is going to be any missing value. So I was talking earlier about how if we have like NaN or an invalid value, kind of confuses our data, kind of messes it up. And that's mainly because we're processing it differently. So this way, by returning the is null and returning that Boolean data frame, instead of having NaN as a value, we can just have true. So that way we can compare true versus false. I just think that's easier in general. And then we have the .sum function, and I'm sure you can infer what that one does. But basically, the .sum function sums all the true values like via each column, and that's just going to give you the number of missing entries per column. So this is like on top of that data frame that we're returning with all the true values. We want to see what values are like true, how many values there are. So that way, for each of these different types of columns, these different types of categories, we can see, we can see how many missing entries there are per column. But yeah, so that's why we did that. And I'll just play that so y'all can see what that is. Yeah, that one was a little quicker. But yeah, this is what it looks like. So it like includes all of these values. It gives us like an average number. Like I was saying, gives us these columns like count, unique, top, frequency. And then this one just tells us like the true versus false. So yeah. Like you can see the top values. Obviously, like sometimes once you start going into some of these, you can't get like an average of like the town they departed from because that doesn't make sense, which is why you see NaN there. But yeah, that's like a quick overview of the Titanic data set. And we can do the exact same thing for the housing data set. So we can do print housing underscore df dot describe. Exact same thing as before, but a little bit faster because it's basically the same thing. Okay. Sorry. So yeah, we're counting these two functions. Like I said, numeric columns versus like counting missing values. And initially, like it would be a 0. So you can see this works a little bit better than this one, just because the California housing data set is more fully numerical, whereas the Titanic data set is a mix of categorical and numerical. So yeah, that's why you can see a little bit more average values, and you're seeing 0 for now. But yeah, you can just get like a quick summary of these statistics. Can be separate the summary statistics because everything looks meshed together. Yeah, we could also do that. That's totally. It's a good suggestion. Titanic.describe clue equals. I'll be like, I feel like you always have really good suggestions. Like, I feel like I kind of just think, like, in terms of, like, okay, how can I do this string? But you're always like, but what if you did this? And then I'm like, ooh, that's helpful. That would make the data better. So let's do that. Ah, yeah, that does look much cleaner. Very nice. So basically the difference here is that we're separating the statistics. So before it kind of had NAN because it's like adding all the statistics together and it's not able to come up with an average, but this way we're able to separate the categorical and numerical. So you can actually see like real values for this stuff. So like if you were wondering like the difference before, this is what all looked like. Just a bunch of like zeros for values or NANs just because we don't have like the 25%, 50% quartiles. But oh, that's not right. I don't know why Command Y just stopped working on my computer. Command Y usually goes back to, I should have missed this. That's okay, that's okay. We have time, that's fine. And this is what the fixed version looks like. Oh, I forgot to print it. That's why I was like, the data went down. And there you go. Yeah, mainly just excluding that like 25-50% statistic because you can't get real data from that. So thank you for that, Fabulous. Very clean, very helpful. Additional ways to clean up your data and not just print out like basically gibberish. So yeah, same thing we did for the housing data set, but you can see we don't have to do that for housing data set because it's all numerical. So it's a little bit easier to get those values. And yeah, now we're just gonna I'm gonna give y'all like a kind of visual for how this data looks like. I think it's really helpful to get like visual with your data when you're trying to understand what it is because it's really hard to understand data sometimes if you're not able to visualize it. So we're going to learn how to visualize it. So I'm going to do import matplotlib.pyplot as PLT. So again, this is another library. Basically this, pyplot. Matplotlib.pyplot is used for plotting data, hence as PLT. And then we're going to do at import seaborn as SNS. Again, importing that data, and then we're going to do sns.hisplot Titanic. And then we're going to specifically pass in the age because I want to show y'all like the age distribution of the passengers on the Titanic. I'm going to do plt.title. And I'm going to do, you can like call it whatever you want. I'm just going to call it like Titan. Okay. I'm fine with whatever AI wants. Titanic AI distribution is fine. Or not AI, age distribution. And then do plt.show. Oh, so let me go over what those commands are really quick. Yeah, this is actually a pretty common thing. Congrats on starting your master's in data science. It is very, I guess, hard to stop using AI as a crutch. I think older generations are a little luckier when they didn't have AI and they were able to get their education. I think it's a lot of being very cognizant that you could use AI but not using it. I don't know if that makes sense, but I think for me, a lot of times, like when I'm doing assignments or like trying to code or trying to learn things, I feel very tempted to just go to AI and get it done that way so I can work on other things. But I think just thinking about what that does to you helps you a lot because when you start using AI and you start using it like as a crutch, you're basically decreasing your knowledge. Like you're not helping yourself, you're making things worse for yourself because you're not really understanding and you're just letting AI think for you. So it's totally valid. I think for me, what's helped is every time I feel like using it, like I kind of think about like how I can use it in a different way. So like if I want to use it on an assignment or something because like something's too hard, like instead of asking it to like write the code for an assignment, I'll be like, oh, like I'm getting this error. Like what are common ways to fix this error? Or like I'm trying to code like this specific class, like what are common ways to do something like that. So that way you're treating AI less like a pair programmer that's literally doing the work for you and working with you and more just like a colleague that you're bouncing ideas off of. Because I think it's really hard to just go like like, this is so weird to say, but I feel like it's weird to like, it's hard to like quick AI cold turkey. Like you can't just like stop using it because I know that it's hard. So just like slowly start weaning off of it and start using it more and more for explaining things and kind of like talking um, through your thoughts with it instead of just having it outright do your work. Yeah, so that's why like on my streams also, like I try not to use AI as much as possible, even when it auto completes exactly what I'm thinking. Sometimes I do, sometimes I'm like, okay, that way. Like just now I was like, oh, the Titanic AI age distribution like makes sense. But yeah, hopefully that helps. Sorry for that tangent. But yeah, that's something I think about a lot, just like how to be more competent in the age of AI. So let me know if that helped and if you have any more follow-up questions. But yeah, let me go back to explaining what this is. So I talked about how this is used for plotting, and we've got like our plt.show. This is very, I guess, intuitive. Plt.show is literally just like showing us what the plot looks like. Then you have your like, was it supposed to do Seaborn or SMS? No, I did. Like technically this is Seaborn.hisplot, but I again SNS because I imported it to make it a little bit easier. That basically creates a histogram of ages, like the counts of ages, and kind of helps you like kind of range through the age data and like makes a histogram out of that basically. You might be wondering what this section is. KD equals true is basically like putting a kernel density estimate over our histogram, and basically what a kernel density estimate is it's just like a really smooth curve over your graph that shows probability density. So instead of just having a histogram, you can have this KDE like set to true, so like a kind of a feature of your hisplot, your histogram. It just shows the probability density like as a curve. So there's a lot of features in the hisplot like function that you can do. This is just one of them that kind of helps you visualize your data. And yeah, that basically just helps us to see the age distribution and kind of just see like very clearly any gaps or missing values. So let's see what that looks like. Zoom out for a little bit, but yeah, this is what it looks like. So this is our histogram of the Titanic age distribution. It's got our count and it's got our age. You kind of see the age range, and then we've got our fun, like not fun, useful kernel density estimate over here. So you can, I guess you don't really need the kernel density estimate because it follows the shape of the graph, but I think it's a really useful visual for when you have more complex pieces of code that you need, I guess, to visualize easier. So yeah, from this you can kind of infer, I think an important part of like learning about data and learning about machine learning is also learning about how to infer your data. And here, like, you can infer that the main significant amount of people that were on the Titanic were kind of in their mid-range of their life, like kind of 20s to 40s. There is a significant amount of like babies and like children, but not that many older people. So yeah, always try to make inferences about your data. That'll help you be, I guess, a better data scientist, and also helps you understand your data better so that when you start working on projects with it, you can think about more like complex ways to use your data and go through your project. So we're going to do the exact same thing, well, not the exact same thing, but something similar with the housing data set. So I'm basically just going back and forth between data sets and showing you the same features in both, just to show you that like regardless of what data set you choose, whether it's purely numerical or numerical and categorical, you can go through both data sets and you can use both. So here I'm going to do sns.heatmap. So this is not a histogram, this is a heat map. If you don't know what a heat map is, basically it's just like it's hotter or like deeper in color or darker in color for areas that are more dense, and then lighter for areas that are less dense. And it helps just visualize like kind of the density of your data set and the frequency of your data set. So we're going to do this. And then we're going to do CMAP. I'm going to do cool warm, and that's how I like making my heat maps. And we're going to set the annotate to false because I don't want the annotation. We're going to do plt.title. Again, you can call your title whatever you want, just so it's irrelevant. I'm going to call this like housing feature correlations. And again, I'll do that plt.show that I had before. So here, for this specific one, you'll notice I did something different. So here I did like histoplot. Here I did df.core. And basically what that does is we are like computing pairwise Pearson correlations between the different numeric features of the data set. Okay, wait, let me backtrack. I think that sounded like too many words. Pearson correlations help you understand how correlated data is, so how strong the relationship is between pieces of data. And we're just calculating that to help us create this heat map because the data set can't just create the heat map by itself. It needs like some additional data help. And then we have this SNS.heatmap function. And it's basically just helping us visualize these correlations, like these Pearson coefficient correlations, as colored cells. So you'll see in the heat map, but basically what this is if there's a negative correlation, meaning that like as one increases, the other decreases, it's going to be red. And if it's positive, which is both increase at the same time, both decrease at the same time, it's going to be blue. A heat map is just as useful as a histogram, just useful for different things. So the heat map will help you be able to identify like very highly correlated features that can help you like determine like why things are happening and how you can group different things together that happen together. So I'm gonna run that and we'll see how that's going. Oh yeah, so you can see our like fun little heat map over here. We've got our different columns, and again, we've got the columns here and here so that we can see the correlation that each of them have with each other. You will notice here that like there's a line of red like straight down this diagonal, and that's because red means like very highly positively correlated, and that's because these are the exact same factors, which is why it's dark red. But then you'll notice that like some of these other features are like either negatively coordinated or vice versa, like latitude and longitude. That makes sense because like the higher you go, like values change. But it's really interesting to kind of just like understand heat maps and see what is correlated to each other. So like the medium income and the medium house value, those are pretty decently correlated with each other. And same thing with kind of the reverse too. You'll notice that like it's kind of symmetrical across this in some places. So yeah, again, making those inferences about data and understanding your data, like this makes sense. Like if someone has a higher income, they're more likely to have like a higher house value because they most likely bought a house in like a more expensive neighborhood, and vice versa. So yeah, just another way to visualize our data. So we had our histogram here, and then we have our heat map here. Note that you couldn't really use. So you could use the histogram for this. That would help you with like different counts of like a specific column, but you couldn't use the heat map for the Titanic data set mainly because, well, not for all the features in the Titanic data set because the Titanic data set combines categorical and numerical information. You can't really combine categorical information into a heat map because heat map uses the Pearson coefficient, which relies only on numbers. So since you can't use numbers for that, it like isn't possible. Okay. Yeah. So now that I've shown you a little bit of the visualizations, I'm going to kind of transition into what I was talking about earlier, which is like handling those missing values and cleaning those missing values out of your data set. So let's start with the Titanic data set. I'm going to do Titanic, and I'm going to do age, and I'm going to say Titanic, age, fill NA, Titanic, age, dot median. So basically what this is doing, obviously like I was saying, it's helping handle those missing values, but specifically what it's doing is like, I'll go like kind of section by section. So this here is selecting the age column. So if you're curious about what it's returning, it's returning like a Panda series object, which is basically just a section of the Panda data frame. And then next we have this like I'm not really going to order. This is kind of a like logical order. We have the median, which is computing the median of all these values. And I know that before we were having that problem where when we were computing the median, like we had NaN values and it was kind of like weird. So the median function here ignores those NaN values because they don't factor into the median. And then we have this fill NA function, and it basically just replaces all of the NaN values with a specific value. So returning that Titanic age. And so that way, at the end of this, like by the time we run this code and like show it, the age column won't have any missing values anymore, and we can use the median as an estimate. Like before, we couldn't really do that because they had some NaN values. But this way, when we clean the data, we're able to get those values a little bit like more back. So yeah, that's a little bit about that. And I know like previously I was kind of running the code and like writing it and then running it, but we're gonna start going more into like writing the code and then running it at the end, just because I taught you like basic how to visualize the data. So then we can do something similar with the embarked to see like where they embarked from. So like where their like stop was, where they left from. So I'm gonna do embarked equals, and then Titanic embarked dot fill NA, pass in Titanic there, and then I'm embarked dot mode, pass in the 0. So basically going through this again, we're getting that Titanic embark data, and mode here, if you don't know like statistics or you just kind of forgot, mode basically just returns the most frequent values. So that's going to return the most frequently, or the most frequent cities that passengers embarked from. And here we have 0. We're doing this specifically so that we select the first mode, so the most common value. We don't really want like the top 5 or something like that because we just want the most common value. We don't want like all of them. So yeah, we use that 0 to indicate that we want that first value. And then we have this fill in A right here. So it's basically just going to replace the missing embarked values with the most common value. So I know you like maybe you're wondering like, oh, like doesn't that kind of take away from the integrity of the data because we don't have that data and now we're assuming. And that totally does make sense, but I think a lot of data science is kind of inferring patterns and deciding things. So it's helpful for us to clean that data so that we can make more analysis on that data set. That if we don't have the data, we can just infer because like we most likely will never find that data out, given that a lot of the Titanic passengers are like either didn't survive or they are no longer alive. So that's a common case with a lot of data is that once you collect it, like it's really hard to kind of go back and find missing values. Yeah, so that's why we fill in those missing values. And again, we're not using like random values. We're using the most common values. So like if we're talking about probability and likeliness, it's very likely that that was the first mode. Yeah, okay. And then we're going to add in another line here. Oh, I did not mean to do that. Then we're going to do Titanic equals Titanic dot drop columns equals deck. There you go. So basically what this does, it just the drop function when you pass in specific columns removes that column entirely. And the reason why I did this was because I was like going through the Titanic data set before. The deck is missing a lot of values. Like you can even see in the first 5 values, you already have 3 nans. That's 3 out of 5. Like that's more than half. So it's like, I think I was looking at it and it was like almost like 75% of the values in the data set were missing in deck. So basically just remove the entire thing just so that we don't have to worry about that. Yeah, and you can do that a lot with your data too if you know that something wasn't collected properly or like something may not be as accurate, you can just drop that data. Obviously, don't do this too much. You don't want to mess up the results of your data, but it's okay to drop things once in a while if you're not using that specific data, just so that you can make further analyses on the data. So we're going to do the same thing with the housing set as well. So I'm going to import numpy. So let me just double check. Sorry, my computer is freezing. Okay, we're fine. So here I'm going to do import, and usually we do import statements at the top. I'm kind of just like sectioning off our code from Titanic and housing, so it's fine if we do it here, as long as we don't use numpy earlier, which we don't since we're not using it for Titanic yet. So we're going to do housing, setting back to housing, and we're again doing the same thing, handling those missing values. So we're going to do log housing underscore df dot sample, pass in that fraction 0.05. And then we'll do dot index, comma med, which is like, medium income, and then we'll do one more line. We'll do housing underscore df. Ooh. I don't know where these brackets go. They just disappear sometimes. We do medic. And I spelled housing wrong. Dot fill na housing underscore df. I feel like I'm talking about like a medical incorporation, hence medic, but it's literally just median income. Some acronyms are really interesting. Yeah, so here's specifically what I'm trying to do. So let's start off with this fraction part. This is basically just randomly selecting 5% of our rows, just so that we can have those. And dot index is going to get the indices of those rows. And this like lock function, and like I'm passing in like indices, comma, metinc. Basically what that's doing and setting that equal to np.nan is setting those values to like missing and like incomplete data. And so that way I can just like show kind of how that data would be set to specific missing values. And then I do this fill na function, which we, I think, used before. Maybe. No, we did. Okay, that's okay. Fill na basically just fills in missing values. Wait, I swear we did that. Oh my god, we did. I was like scrolling up for no reason. Yes, we did that here. And it's just going to fill those in with the columns mean for median income. So just kind of like showing you an example about that. Housing, distribution for all the numerical value in the data. Yeah, that's definitely something that we could do. I'm more so going more on like a, I guess, box plot for the Titanic. So yeah, I guess yeah, we can try that. Why not? Not really. I am definitely open to trying new things. But yeah, this is another way that we can kind of display that data. I think this was in reference to me saying that we shouldn't use the histogram for the housing set data. Yes, there are definitely ways that we can use histograms, like distribution for all the numerical data. It's like specifically focusing on the numerical data. It was more just like a different way for me to show you also like the housing here. So, but I agree with Abiolek. We can always try new things. So let's try that. Yeah. Thank you, Abiolax, for that. So if you were curious about how the housing data looked via histogram distribution, that's how it looks. So yeah, it takes the numerical data and it's able to go through all of the different ones. Or actually, sorry. Yeah. Wait, no. I think I confused myself. It did say we can use histograms for the housing data, but we didn't. But yes, Abiolak has shown us a way that we can do that. So you can kind of see the histograms for that. Yeah, it looks like average occupation is just like very stagnant value, but you can see some of these kind of fluctuate back and forth. Obviously, the average rooms isn't going to go much past like that, whatever number that is. Yeah, super cool. Thank you for that, Abilex. Yeah, I guess coming back to this part. I talked about what fill in A was. We're good to go there. Yeah, okay. So now that we handled those missing values, we can also handle kind of like inconsistent values. So sometimes when we get data it might be reported inconsistently. So what that means is like we might want things structured one way, but the data might be structured another way. So like maybe people misspell, maybe people are using abbreviations where they shouldn't do that. If any of you are hackathon organizers, you'll know that a lot about your registrant data. I made a couple of forms for my hackathon, and I put in your country. I forgot to mention that you should put in like the country code, not the full out word. Or I think I did that for grade level. I did something, and then I got results, and I was like, oh my god, this sucks, because I couldn't even filter based on like specific categories. It was like really annoying because like I had to go in and clean the data. So that's why it's really important to standardize data. And if you're not giving like very clear instructions, like I did not do, you should at least do like multiple choice, something like that. Sorry, that was like a side tangent. I don't know. But yeah, we're going to handle inconsistent categories within the Titanic data set. So now we're switching back to Titanic. Sorry, I know this is like a lot switching back and forth. I just don't want to make new code blocks because we're not printing anything. But yeah, we're going to go into the Titanic stack. So male versus female. Like I think it was just because like sometimes male versus female is misspelled, or it's like M and F, because that data just wasn't collected as properly as the rest of it. So we're just going to make sure that that is consistently collected. So we're going to do Titanic, and we're going to do Titanic, and make sure that we're referencing that again. Ooh. Sorry, I'm trying to get just make sure so I don't like break my back. But and then we're going to do string, strip. Very, very long line of code. Could probably break it up into a couple lines, but I think it makes sense. So basically we have the str function here, and that allows string operations on a series. So basically like a panda series is not a string, but if you do like .str, that will help you convert it into something that you can use for the string operations. And then we use the .strip function, and that basically is removing any leading or trailing white space. Then we've got our .lower function, which is basically converting any text to lowercase. So again, like standardizing it, maybe they did caps M, caps F for male versus female, but this way we can make sure that it's standardized. And then finally, we've got like, I think as a result of this, we'll have like a uniform column. Give me 1 second. Okay, sorry. I had to go get a pillow. My back kind of like is hurting. I'm not sure what's wrong there, but we're good. Yeah, so that is how we can handle some categories that might be inconsistent categorical data. And now we can kind of go into how we detect outliers too. So I'll do the same thing here. This is going to be a piece of code that we're running. I guess this is kind of the last piece of code that we'll be running. Or before we like do the final one, we'll do sns.backplot. And let's take a quick break after this, but we're going to do Titanic. Ooh. And we're going to do fair. And we're going to do guilty match. So basically, this is going to create a box plot for us. If you don't really have that much experience with statistics, or you just don't know what a box plot is, totally valid. But box plots basically show us quartiles and whiskers. Like people kind of think of them as like cat whiskers, but they just help you tell you like different pieces of data about or pieces of information about your data. These whiskers kind of serve as a boundary, because the values outside these whiskers or these like lines are considered outliers. And outliers are not really great because they can kind of distort your models. And if you have outliers, then you're kind of opening yourself up to biased data. So that's why it's just important to see the data. I definitely spelled Titanic wrong somewhere. Where is it? Uh-huh. I don't know why I keep typing Titanic, but yeah, this is the box plot. So this is like the box, the quartiles, and the like kind of whiskers. So you can see that we have a lot of pieces of data that are outside. So maybe these fares were just like last minute purchases, or just like not normal. Maybe these were like for higher classes. So yeah, we can kind of see the outliers, and this is like a way to determine like what your outliers are and see how many you have to see how skewed your data might potentially be. So we're gonna take a quick like 2-minute break, or actually 5-minute break, and we'll come back in 5 minutes. I don't know if we have like a timer or something. Probably not. Yeah, we don't. But I don't know what time zone it is for y'all. Just add 5 minutes to your current time. For me, it's like 7:11 p.m. So that would be like 7:15 or 7:16. So just make sure you come back in 5 minutes. I'm gonna get started, and I'll just make sure that like everyone's time to be like, okay, is everyone good to go? And if you're like still taking a break, just let me know. But yeah, we're just make a quick break. I'll play some like music in the background so you're not bored. And if you want to get a head start, just like review all the code that we've written so far, because we're just going to make like a really big project and like combine all of it together. And I'm going to show you all like how to try different models with machine learning. So actually getting to the machine learning part after like going through all the pre-processing steps. So let's start our break. I'm just going to play the music and then I'll hop off screen for a little bit. Hello! Hopefully you enjoyed that little break. Yeah. We're gonna get started back with our project again. Again, like I was saying, if you need a little bit longer or you were like getting a snack or something and you need some more time, just put it in the chat. And I can wait for a little bit, but if I don't see anything, I'm gonna get started. Hopefully you all enjoyed that little 5-minute break. We're just gonna build like a really big, long section of project now. I'll add in a couple of things that I guess I didn't talk about before, just like additional features that you can do with your data sets. Most of it is just going to be what we were talking about before. So I'm going to do import pandas and as PD. And this time we're going to import numpy as well as np. And then just I'm going to import a bunch of different things from scikit-learn. So this is a lot of things that we can use to kind of help us with our code and to kind of like take us, I guess they're different not instructions, that's not the right word, different sections of code and different ways of learning. So let me go back. Just open up the code here. Okay, so I'm doing numpy here. It basically, we're using that again. We did the Titanic Fair, and I'm just going to import a bunch of libraries. I will go over why we're using them when we actually get to that part, but feel free to just follow along and type with me. We will definitely be needing these, so don't worry about that. It's asking me to import random stuff that I don't need, so I'm not going to do that. Sorry, I went nonverbal there for a second, but there's just a couple of import statements that we're going to need to work out our rest of their code. Network issues and missed out a bit. No worries. Hopefully you didn't have network issues while I was running the previous code, but if you didn't do any of this, just let me know and I can copy paste the code in chat for you. But yeah, basically we took like a 5-minute break anyway, so I think you should be good. And then I just started typing what was on the screen. So let me know if it feels like you're missing something or you have no idea what's going on here, and I can go back and explain a little bit more. But this is all we just started doing. We just started importing some data. And again, we're going to do the same thing and load that Titanic URL. So I'm not actually going to type that. I'm just going to go back and grab that over here. So again, we're doing this whole new like kind of code cell just so that I can show you how to like start from scratch. Like I did different segments to show you how that looks like, but now we're going to go through a different set. So I'm actually going to use a different data set here. I don't know why I copied and pasted that, because I want different column names to show you all like different data sets, I guess. There's not one way to go through what data set you want. There's a lot of different pieces of data about the Titanic. And that's what you'll find with a lot of things too. Like a lot of people have done different studies, collected different pieces of data. So you'll find that a lot too. And here I'm going to pass in, I'm going to call this Titanic URL actually. So it's not the same thing as it was before, but I'll still call that Titanic. Cool. There you go. And I was talking about feature engineering earlier, so let's go into it. Let's do feature engineering. So basically here, I'm going to do this like kind of like transform log thing. Let me see. I'm trying to pull up like what I specifically wanted to do so that I wouldn't go too into it, but I think I might have just wanted to do it. Okay. So let me just write it. I'm gonna do Titanic, and here I'll do brackets, do fair, Titanic, brackets again, fair. Here, using that fill NA function that we used before, just filling it in for 0. If you don't have value, I guess your fare was 0. You had a free fare. And then Titanic again. And for that fare bracket, we're gonna do lambda x and log x. Okay, probably looks a little confusing. Let me explain that what I is. So basically, we're gonna ensure that there's no 0 or no negative fares before we log transform. So yeah, very useful for us so that we can make sure that we are replacing those missing fares with zeros, and so that we can use that lambda. Basically, that NP is going to compute like log parentheses x plus 1 for any 0 values. So if we still have zeros, it's going to be able to use NP for that. And the dot apply, we're using that function like element to the series. Then we're filling that missing fare in with 0 so that we don't have that like NaN error. Yeah, and then we have log transform there so that we can like kind of decrease the importance of like very extreme fare values while we still maintain the order from like low fare to high fare. Yeah, so I'll talk about like why we use certain imports. Like I just kind of like imported things now so that like we can get the import statements out of the way, but we're going to be talking about like what specifically we're using these things for. Copy the code. No. Okay, perfect. If you do need it, let me know, but it looks like you got that. So yeah, that's what we are doing for feature engineering. And then we're going to like kind of go through the titles and clean up the titles there. So if you notice when we were going through the data, we had like a couple pieces of data about the titles. So we're gonna go ahead and clean those pieces of data up. String.extract. This is going to be a very complex expression. Pay very close attention. But basically, all this is doing is it's using regex, which is like the language of regular expressions, to extract titles like Mr., Mrs., and Miss. Like under the name, we're going to have like John Smith and like Billy Bob Joe and like Mary Jane, but like we just want titles specifically, hence like why we're creating this new title column. So that way we can use regex, which is like a really cool programming language, or not really programming, but it's a cool language to extract these titles so that we don't just have names and titles. That way we can organize. So we're going to use extract, and I'm going to do -ca -c. I worked this out before, so I think it should work. Fingers crossed. But we'll see. Expand. Oh. Okay. And then we're going to do that again with another title section. So here we're just like merging like a couple of different variants. So like replacing different things that people used to call people back in the day. So like we're mainly just focusing on like Mr., Mrs., and Miss, but sometimes people would use like MLLE or MS to refer to a Miss. So we're just going to replace that because otherwise we have really weird pieces of data that basically mean the same thing. Like we're not really getting any extra value from like MLLE and MS compared to Miss, and this helps clean up our data and helps it make it easier for us to process it. So this is a cool way that you can still maintain the initial intent of your data, but also like be able to clean it up and get a little bit more useful for you. So we're like really honing in on that title here, but doing the same thing, people would also do like MME for like Mrs. And I don't, by the way, just know this like off the top of my head. I did some research about this data set before I used it because I didn't want our data to be like wonky and wrong. So yeah, I'm not like secretly into like the 1900s or whenever this happened. I like Googled it. So yeah, okay. And then we're gonna do one more title, focus. And we're gonna pass in RAM. So this one, I guess, is a little bit less intuitive. So what this one does is it basically just ensures that there's no missing titles that are left. So if like someone didn't have a title or like their name didn't have one, like they just had like John and they didn't have like Mr. John or something, that just helps us fill it in with rare. So it's like something weird. Or maybe they had another word that was used for like Miss or Mrs. that I couldn't find when I Googled. So we're just using rare there. And then we're going to look at family size. So I'm going to do Titanic. Family size. They didn't really have like, I guess family size is an inherent piece of data, but we can gather that. So we're going to do SIB SP. And basically what that is that's like siblings and spouses. So like siblings and spouses are part of the same family. And then we can do like Titanic. And we can do arch. Oh, it's actually supposed to be in single quotes. I don't know why I'm using double. And parts is parents and children. Okay. And then we're going to add one. So basically what this is doing is it's combining, like we're saying like one family is a sibling, a spouse, parent, a child, and the passenger themselves, hence this extra one. So that way we have like family context. We don't just have like individual passengers by themselves, but we know like it was a family and like kind of how that worked. And then we can do the same thing with name length as well. So just like additional pieces of data that we can gather. Like these are just like different ways that we can gather important pieces of information. So let's check that. And then we can fill in the missing age values as well. Just the basic stuff that we've been doing with all of it. Oh, not median, median. Okay, perfect. So here, again, using that fill in a function to fill in those missing values, doing the same thing we've been doing. And then we're going to do something, I guess, kind of like a little bit more unique. We're going to like use scaling as a feature. So basically, scaling just helps us standardize features to values that we can use. Its end goal is to ensure that like when we have numeric data, it's comparable to each other. Meaning that if you have data that is like really small and also really big, it's kind of hard to compare those two. So that's why it's really useful for us to be able to use the scaling feature. And yeah, I can explain that. So basically, that's just me making a new feature like called family size. So basically I'm using specific pieces of data, columns of data from the Titanic data set. So this is part 2 of the Titanic data set. I used a different data set earlier because I wanted specific column names and now I wanted more, so I used a different data set. But basically SIB SP stands for siblings and spouses. PARCH stands for parents and children. So this is just getting like the data of the people on the Titanic and their family size. So I'm just making like a new variable, calling it family size, adding like siblings, spouses, parents, children, plus the passenger itself, hence the +1. So I guess this doesn't really do anything inherently like in the code, like it's not a piece of coding syntax that you would need to know. It's just more like helpful for us to kind of have that information and add to the information that we do have. Okay. So kind of going back to scaling those numeric columns like I was talking about. So we're going to do something here. We're going to do scalar equals not scalar. scalar equals standard scalar, and we're going to do here, we're going to do numeric calls equals age, we'll do Fairlog, and then we'll do, so we are just passing in all of the variables that we made earlier, different features, and then name length. So these are all its scalar value or numbers that we can use, and we'll do transform, parentheses, Titanic, numeric underscore calls. So in case you were wondering, like, specifically what this does, like I was talking earlier about how, like, the standard scalar specifically, basically what it does is standardizes those features. That way we can get a mean of 0 and get a standard deviation of 1. So that way, like I was saying, we can compare pieces of code that have different pieces of magnitude. And then we have this .fit underscore transform function. Basically what this does is it computes the mean or the standard deviation on data that's like similar to training, and it scales each of those values. So that way we can keep that standardized mean of 0 and standard deviation of 1. Again, like I was saying, end goal is just so that we can compare different numeric features that may or may not have different magnitudes. And then we're going to use encoding. So Titanic encoded equals pd dot get underscore dummies. Titanic will pass in our specific columns that we wanted and that we used, and we'll pass in the sex of the passenger, we'll pass in embarked, and we'll pass in title for what their title was, comma, and we'll do drop first. It's true, we want to drop that first value. So basically what this is we are converting all of the categorical columns. So, sex, embark, title, these are not columns that can be numerized. Yes, yeah. Like I mentioned earlier, we're using 2 different data sets. So you'll notice that the URL here is different. So here, I guess I can show y'all what this URL is too. This is the second data set for what we're using right now, and this is the first data set. So you can notice that the columns are different. This is mainly just because I wanted like a little bit more data and I wanted to show you all 2 different data sets. Yes, it is different. Let me paste that. Sorry, it also includes the Titanic variable, but just if you don't want to call it Titanic URL, just call it something different and make sure you use that URL. Yeah, make sure you are using the new URL for this new code segment, because if you use the old URL, it's not going to work. Yeah, of course. Yeah, so going back to the code. Yeah, you will get an error if you try using the old link on this new code, because the old code doesn't have these columns. So for the encoded function, basically what it's doing is converting the categorical columns into binary indicators, so either 0 or 1 for each category. And drop first equals true basically drops 1 category per feature, just making sure that like not everything is like going together. And it just helps clean up that data like all that bit more. And then we're going to do the same thing with like dropping some pieces of dropping some columns that aren't numeric and like aren't really useful in terms of what we're trying to do. So I'm going to do that now. So I'm going to do encoded.drop. Actually, I'm just going to click tab this time because it kind of has what I wanted. So we're going to do columns equals, I'm going to survived, name, ticket, cabin. I do want fare, so I'm going to delete that. I want fare. I don't need passenger ID. I don't need their boarding date. But specifically, like if I don't need their boarding date, if the boarding date in Titanic coded, else I just want the brackets, perfect. Okay, and here I'm going to pass in axis of 1, and any errors, I'm just going to set errors, going to set that to ignore. Why is it red? Yeah, so like we're removing the models that we don't need for prediction. That's why I'm specifically removing those. I think there is an errors. Let me just oh, it's because I don't need to set the columns. That's on me. Okay, so I think we should be good there. Okay, sorry, I renamed some things wrong, so let me go over what I did. So basically, we're not going to use that function that I was using earlier, the like columns equals. I think I was reading this and I was trying to type and I was looking in the wrong place. But we're just going to drop these columns because I don't need them. We're specifically only dropping the boarding date if it's already in an encoded column. Otherwise, we'll just keep it blank. And we're just going to ignore the errors because we don't really care about them. And yeah, we're going to keep this the same, and we're just going to encap the y as survived. So yeah, this is kind of getting more into the machine learning part where we're training and testing the data. So here I'm going to do like a train test kind of split with my data. So let me go ahead and do that. So I'm going to do x underscore train, comma x underscore test. So just like very basic machine learning stuff, what you always do with training and testing data. Train test split, x comma y comma test size. It's already got it, knows what I want, but let's manually type that out and then random state. So just setting my testing data here, just setting in that random state. And then I think it was Abiolex that was asking what the pipeline was for. So yeah, this is what the pipeline is. Split pipe equals pipeline, do brackets, and then we're going to pass in the parenthesis, do model, parenthesis, logistic, regression, underscore hitter equals 1000. Oh, the brackets are already there. Perfect. And yeah, that's it. So basically what this does is we are chaining together the pre-processing and the modeling of the data. So we already did the pre-processing, hence like the lengthy list of things that we did. So we're only including the model here, which is why we just pass in the model. We're not like passing in data to pre-process. And that's what we're using the pipeline for there. We're using logistic regression here. So after we do that, we are going to do pipe.fit. We're going to pass in x underscore train, comma y underscore train. And basically what the fit function does is it trains logistic regression. So it uses our training data and helps fit our data to the logistic regression model. And then we're just going to print the accuracy. So we're going to print Titanic accuracy, and then we're going to pass comma pipe dot score underscore test underscore test. Okay, so now that we are basically done with the data, I'm kind of curious what we all think the accuracy will be. So what do you think the accuracy will be? I wasn't able to type that long link that dropped the features we don't need. Yeah, for sure. Yeah, it is pretty long, very valid, and I also messed up a couple of things, so very valid. I also zoomed in, so it's kind of tiny, but yeah, let me, it's not letting me highlight the entire line. Oh no, I'm opening up a dictionary. Oh yeah. So the pipeline we specifically use, we're using a logistic regression pipeline, and we're just using this to see the accuracy of being able to see like how our model is able to detect whether or not predict whether or not somebody survived based on like a lot of different columns. Specifically, like the columns that we used were like like where they embarked from, like what their title was. So kind of like indicating where they were, and then like age, values, family size, name length, and that's what we're using to predict whether or not they survived the Titanic crash. So that's what we are using that for. Hopefully that helps a little bit. But yeah, so that's what we are doing. So I'm just gonna go ahead and click play, and y'all can do that too. Ooh. Data frame object has nothing test. Okay. Oh, because I did a dot here instead of an underscore. There you go. Okay. By the way, if you didn't catch that, I just accidentally did x dot test here, but it was supposed to be x underscore test. So there you go. There's the accuracy. Yeah, I was gonna ask y'all like to guess what the accuracy was, but I don't think that would have been possible anyways. So yeah, that's like a way that we can use data that we've cleaned and pre-processed in our machine learning models. So here we were able to look through and train our data based on the Titanic accuracy and be able to see like how accurately it was able to predict whether or not somebody survived based on like these columns that we passed in. So like age, fair log, family size, name length, so a couple of different factors that people collected and see if that data was useful. So yeah, that's a little bit about, I guess, the data. And yeah, I just wanted to talk a little bit about like, so that's kind of like the end of the coding portion. And yeah, I'm going to talk a little bit about like why data quality is important and just a couple of things to wrap up the stream because we are almost done. So basically, I've been talking a lot about how it's really important to pre-process data and how it's important to clean up data. And that's mainly just because, like, I'll tell you now why we did everything that we did and like what negative effects it could potentially have on your data. So for example, if you have a missing value could mislead the model. So like think about if you had like a missing age or a missing fare, that would be a problem. That would mislead the model. Can't see the last line of code. Oh yeah, no worries. Hopefully that helps. And if you have, oh yeah, actually, before I keep jumping in talking, gonna get like a thumbs up or an emoji or something in the chat to indicate that y'all also got this working. Because if you're having errors, I would love to help and help y'all figure that out. So just send me a message if something's going wrong or something's not working, or if something did work. Yeah, I'll keep talking. And also like we accounted for outliers too. If we have like really high fares, like maybe they bought it the minute before, or like unusual family sizes, like lots of children, or just like values that aren't possible potentially collected wrongly, that could skew the results. So it's important to account for outliers there. And yeah, that's why we like went through and pre-processed the data. We handled that missing data. We scaled the features. We specifically encoded like categorical features so that way we can like make sure that if we have categories that aren't able to be encoded via numbers, they can be, or yeah, like something like sex, like it's male or female, but we could do 0 or 1 to help us a little bit out with that. And also, like, I guess I didn't explicitly define this, but feature engineering is basically just creating new features from existing ones. So we created a new feature of our data, which was called family size. And we actually created 3 new features. So we did like family size, and we added like siblings, spouses, parents, children, and we added the parent themselves or the passenger themselves. And that created a new feature, which was family size. And similar thing, we created a title feature from the name based on the titles that might have been added to names when passengers registered for their tickets. So that is important because sometimes like data might not have patterns, but we can engineer the features to have patterns. Yeah, so that's why it's a little important to be able to create those new features. You can have
a lot of different features within data, and it might not reveal a pattern, but once you engineer these features to do so, they will be able to do so. And yeah, we use logistic regression. Kind of the way that works is like you assign weights to each feature, and then like if you have a positive weight, that increases the chance of outcome. If you have a negative weight, that decreases the chance of the outcome. Yeah, and that's like a little bit about how linear regression, linear models works. Yeah, that's a little bit about like a little kind of quick wrap up about how data can relate to machine learning and why all the pre-processing that we did was important. So yeah, we fit the model on the trained data. Please, where do we predict on the data? Yeah, so pipe.score does that automatically. That's why we passed in the test data. So you can see like if you hover over pipe.score, it'll explain to you that it transforms that data and then applies the score with the final estimators. So here we trained it. That's why we did pipe.fit. And then pipe.score helps us test. So it's a little bit different than like training or testing manually because the pipeline comes with that automatically. So yeah, good question though. Yeah. So that was like a quick intro into pre-processing data and how you're able to use that data for machine learning projects and just for projects in general. Let me how do we now get the predictions? Yeah, so that's the score that will be outputted. So that's why you see like Titanic accuracy here. That's what the model predicted. So we're not going to see like the raw predictions that like you would have to like go in and like try to code that to get the model to output that. We're just going to see the accuracy. So like we won't be able to see each prediction the model makes. That would take like separate, like making it specifically output, like printing it out every time it like tries to iterate through the data. But with score, we're just able to get like the average of like what the accuracy was, how accurately it was able to predict whether or not somebody survived based on the features that we used. But yeah, so that's kind of that's like the tail end of the stream. I'm gonna pass in a couple links like I always do at the end of the stream. First, we're going to start off with our feedback link like we do every time. So hopefully y'all enjoyed this stream. If you did, please make sure you put some feedback on the stream, or even if you didn't enjoy it, just put the feedback in. It helps us improve for future Global Hack Weeks. And on the topic of future Global Hack Weeks, talking about what is up next, we have Vincent up next, actually, going over their getting started with databases on AWS, Intro to Amazon, RDS, and SQL. So if you're interested in databases on Amazon and AWS, check out Vincent's stream over here. Going back to the feedback. Yeah, that's kind of the end of the stream. I hope y'all enjoyed kind of coding along on this project and learning more about data sets and how to pre-process data and how to use them in machine learning projects. If you enjoyed, please make sure you fill out that feedback form and go to Vincent's stream. It's happening at 7 a.m. GMT, so in a little bit from now. So yeah, maybe y'all will be interested. It's like 3 a.m. to 5 a.m. EDT from now, so maybe like 7 hours, 6 hours from now. So it's going to be in a bit. So maybe take a nap, get some sleep before the next stream, or just go about the rest of your day. I don't really know what y'all are going to be doing after this. But yeah, thank y'all so much for joining. I'll hang around for a little bit if y'all have any questions and play some music. But if nobody has any questions, I'm just going to go. So thank you so much for joining, y'all. I really enjoyed coding along with you. Yes, of course. Hopefully you enjoyed this stream and got something useful out of it. But I'm just going to play some music in the background. Okay, it doesn't look like we're getting that many questions. I think everyone is good. So if y'all have any questions, just make sure you ask in the Discord. Someone will definitely get back to you if you have any questions related to the stream soon. But thank y'all so much for joining. Have a good day, have a good night, have a good morning wherever you are. Bye.